I'm John from Team Aeolus. We have selected as our product the Kit Best Compact Bike Pump. It is compact, allowing you to take it on your bike rides and inflate any tire flats that might happen while you're riding. Let me show you its subassemblies. First, we have the handle/air chamber. Next, we have the base, the tube, and then the nozzle. The handle slides over the base and threads on to this retaining nut. Next, the tube connects to the base at this interface, and the nozzle connects to the other end of the tube. These four subassemblies combine to allow air to be pumped from the handle and air chamber through the base, through the nozzle, and into a bike tire.
So we have 7 parts of our bike pump, which were injection molded. So injection molding starts with the mold. You machine the mold for each part, and then once that is done, then you get granular thermoplastic pellets, and you melt them in a machine, which then are pushed through with a lead screw and injected into the mold. Once the mold is cooled, it is pushed out with pins, and the process is done. And so we have 7 parts here. The first one is the base, and then we have the air chamber cap, we have the base cap, we have the handle here, we have the tube caps, and then we have the nozzle and the nozzle handle, which were all injection molded.
Hey, I'm Parker. I'm also with Team Aeolus, and I'm going to be talking about the parts within the current bike pump design that are made through an extrusion process. The first of which is the tube which transfers air through the bike pump. This is made by machining a die to which a stock piece of rubber is forced through that die to make the final tube part. In addition, the pin that connects the nozzle to the nozzle handle is also made through a similar process, but this time with aluminum. So the aluminum is forced through a machine die to achieve the desired diameter that holds the nozzle assembly together.
The air chamber is made by drawing aluminum over a mandrel, creating a hollow tube. Next, threads are machined on either end of the tube, and then the tube is anodized with this Kit Best decal applied afterwards. At Team Aeolus, we attempted to make the manufacturing process for this bike pump easier and include less parts. First up, most of the parts on the current bike pump are threaded, like this handle. This can complicate the manufacturing process and the assembly process because each thread has to be cut and each thread has to be threaded onto a different piece by a human. In our redesign, we incorporated every single thread part into a smooth fit like this that was glued with adhesive. This allows us to retain the strength of the initial connection from the original design, but allows us to increase the efficiency of manufacturing by making it easier and quicker. Next up, we noticed that there were several unnecessary separate parts in our design. In the initial design, it's composed of 10 pieces. So we looked at the handle and the air chamber and got rid of them. We combined them into one piece.
So after deciding on our design changes, we wanted to validate those design changes with a design for assembly analysis. And what we wanted to do here was weigh the original design with our new design and a variety of different factors relating to the assembly of the overall part. First factor is complexity. So our new part decreases the amount of parts in the assembly plus the amount of interfaces. So this drastically decreases the complexity of the overall assembly. In addition to this, the new assembly now has glue instead of threading. So this makes the insertion process of actually assembling everything together much more simple and time effective.
Given these design changes, we were able to remove the drawing process of the air chamber and instead incorporate it into one injection molding process that encompassed both the handle and the air chamber. Also, because of these design changes, we were able to remove all threading operations and instead we'll be using glue as it met our design requirements, but drastically reduce the amount of time for both manufacturing and assembly.
So after completing our design changes and validating these design changes with the DFA analysis, we opted to actually prototype the new design. So this old bike pump design, we don't have much use for anymore. Instead, we have our new and improved design for manufacturability and assembly bike pump. We print additively manufactured, FDM printed, the air chamber cap, base cap, and base pump. While some components of the bike pump weren't able to be additively manufactured, we used the original tube assembly from the original bike pump design to integrate into our assembly, thus completing our newly designed and prototype bike pump.
By analyzing the manufacturing process and assembly process of the original bike pump, we successfully identified changes and designed those changes to improve both manufacturing and assembly process with a new pump.